Determining input and output impedance. Well, the easiest way to determine input impedance is just to take the ratio of the input voltage, Vn, to the input current, which is in this case is the current flowing through Cin. We go back to simulator, make sure that we're running an AC sweep between 1K and 1 megahertz. We're not using multi-step at this point. We're just doing it for the default values of the parameters, and then run the simulator. Then add, this time we want the input voltage, Vin, divided by the input current, which will be one of the currents flowing through Cin, and just write that as Cin hash P. It doesn't matter if it's P or N, it's the same current flowing through the capacitor. That gives me this graph. As you see, the input impedance starts off at around 160 kiloohms or so. You'll note Simetrix is intelligent enough to realize that a voltage divided by a current is a resistance and expresses the y-axis here in ohms. Once you get up to these high frequencies for this particular circuit, the input impedance has gone down to about 2.7K. Okay, that's input impedance. Output impedance is most easily measured by putting a signal into the output, which we do by selecting that and then duplicate it and put it over here. Wire it up, left, left, right, left, left, right, and now we have two voltage sources inputting AC signals into the circuit. That's going to get confusing, so we'll turn this one off by setting its magnitude down to 0. So, we're putting a signal into the output now. That's not the normal way that we measure output impedance in a real circuit, but for a simulator it's a very quick and easy way to do it. The output impedance, rather, will just be the voltage that we put onto the output dividing by the current flowing back into the circuit, which is the current through Cout. Then we run the simulator, and this time put a probe to measure the output voltage, Vout, divided by the current through Cout, which is Cout hash, and again it doesn't matter if you use N or P, I'll use P here. And that gives me this curve. As you see, the output impedance starts quite high-ish, around 1.8 kiloohms, and decreases with increasing frequency, and at high frequencies here it settles to around just over 1 kiloohm. You can zoom up on this by drawing a box around the interesting bit if you want the answer to be more accurate. It is almost exactly 1 kiloohm. Don't forget to remove the additional voltage source here before you take any other measurements. Conveniently do that, delete, select the wire, select that wire by drawing a box around it, and set this back to a magnitude of 1. Save that.